Marine species are dying at an alarming rate due to ocean acidification. Ocean acidification is when the ocean pH becomes more acidic. This lowering of pH in seawater is directly caused by CO2 emissions from fossil fuel combustions in our daily lives. Activities like driving your car are emitting huge amounts of these fossil fuels. These emissions in our atmosphere collect into the ocean, which can absorb as much as 30%. Although the ocean can take in much of the CO2, there is simply too much for the ocean waters to hold without strongly affecting its chemistry. In large amount, CO2 dissolved in seawater alters the pH by allowing the hydrogen from a water molecule to ionize. The lowering of pH value leads towards various effects on both fish and invertebrate species, according to Rhonda, Boyd, and Hurd. These organisms can suffer from defects such as low muscle mass, stunted growth, impaired immune systems, and a lack of eating properly. But what is the cause of all this? Why should we care about the corals and the other organisms that are involved? Coral is a common marine species in the ocean, and most corals have a calcium carbonate structure. Due to the decrease in pH, corals are having a harder time producing their skeleton, making them not able to withstand forces like heavy waves. For invertebrates, the calcium carbonate also plays a role with their structure. The calcium carbonate originates from the reaction that occurs between the carbon dioxide and the water, HCO3 negative, as well as within their tissue. An imbalance of CO2 will lead to shells becoming very fragile. Fish are also dependent upon calcium carbonate in order to form their skeletons, their gill control, and muscular movements. This is extremely apparent in Ambrilla, a North American species which lost its length in the larval stages as it was subjected to higher amounts of CO2. The larvae were exposed to roughly 1,000 ppm of CO2 and developed crooked tails. CO2 emissions are the result of burning of fossil fuels. This includes coal, oil, and natural gas. On average, for every gallon of gas that your car uses, 19 pounds of CO2 is released into the atmosphere. An average car gets 23 miles per gallon, and an average American drives 10,000 miles a year. This means that an average person, just from driving, is releasing a little under 8,500 pounds of CO2, the weight of an average-sized sedan. In total, an American person is releasing about 50,000 pounds of CO2 a year. Close to 1/4 of the CO2 emitted is absorbed by the oceans, and the oceans have become about 30% more acidic. The future of coral reefs and the majority of marine species due to ocean acidification depends on how much CO2 is released and how the oceans respond to the increasing amount of CO2. Already, coral reefs are showing highly negative effects due to ocean acidification, and these outcomes are only likely to result in even greater negative effects on coral reefs and the ocean. If CO2 emissions are not dramatically reduced, projections show that by 2050, the number of corals will die severely, which will move through the food web immediate to us. Unless a dramatic change is made to reducing CO2 emissions, coral reefs will die. Ocean's pH has already decreased from 8.2 to 8.1, equivalent to a 30% increase in acidity. And by 2100, the pH could be at 7.7 to 7.9. Although these differences in pH sound small, it's a huge impact on marine species. If we as a society make an effort to dramatically decrease CO2 emissions, ocean acidification could be halted, and coral reefs may still have a chance of survival.